Hello, in this video we're going to create the buildings from our OCM files. So in here I have already imported my OCM and I filtered out the building parts, which you can see here. And what I will be doing is using the lab's building generator to generate out my buildings. So before I will do this, to save some time, I will also cut out a piece of the map. So right now, if I would plug in the building generator, we will need to calculate all the buildings I see here on my screen. So to make everything a bit go faster, in here I want to cut out some parts. So I will be using a clip node. So as you can see here, placing down a clip node, we'll then have the option to then cut out different parts of my scene. And as you can see now, I only have a few buildings. So what I want to do here on these buildings is use a for each connected piece. So this means I will loop over each building individually. So in this case, I have 26 buildings. I will loop over them individually. So in here, let's just start with one building and plug this in the building generator. And you can see that by default, it will generate all this geometry. Now we also have some settings here. So first of all, like the floor height. So if I would go back here to my OCM buildings, we have set the level height to 4. So we can do this here as well. So we can set it to 4. So we have new levels. Now further, we also have here some primary and secondary options. So primary is for our main wall. Secondary is for top ledge and bottom ledge. So you can enable and disable this. So now the bottom edges are gone, but we can also disable the top edges. So, but in this case, I'm only using the top edge. So I actually want to enable this back. And now I want to, instead of having this plain geometry, I want to have a custom model. So therefore we need the other node called the building generator utility tools. And in here, I can then have a file node for my geometry. So in here, I will look up my FBX file and load in my file. So I've loaded my file and let's plug this in. So now I need to give this a proper name. We can just call it, for example, wall 01. Then we also need to fill in the dimensions of this wall. So we can always double check the sprite sheet. You can filter out here what the highest values are. So in my case, they are 0.95 and 1 in the height. So this can then be plugged in the building generator. So we have to fill in here the wall 01. And now our wall is being replaced. So instead of this geometry, we have now our real modular model that I want to use. So this is the process that I'm going to do for all modular models. So I'm going to load in my model and I'm going to give it the proper name, and I'm also going to set the dimensions. So this might take some time. I'm going to skip this part. As you can see over here, I have now loaded in all these models. So all with the file node, and I have assigned different kinds of sizes and so on. So I'm going to just connect the merge node here and plug that in here. So we can just merge all these different modules together, and we can then filter out by name. Also, to clean up the file a bit or the structure of my node, I can here click on the minus icon and it will collapse this whole structure. So I'm going to go back here to my building generator and I'm going to fill in the new names over here. So I filled in all these values. Now we can play around here with more of the values that we have in the building generator. Like we can tweak maybe the floor height a bit so it fits a bit better. So maybe 3.8 will be fine. Then we can also here have an option. You will find an option somewhere to scale the model. So if you click this, the models will be scaled on the space they have. So in here, actually, this piece right here, all these pieces are new geometry being created for each building. So if there is enough, when there is not enough space, it will generate new geometry. If you don't want that, we can then have a scale the model feature, which then fits model in place. Now, to make this building more interesting, we want to have different variations on different floors. So here at the bottom we have a override floor. So we can just click on this plus icon and now we have different options. So by default here it will set floor index to 0, which means the bottom floor. And I can now override what wall used. So I have a specific new wall for the bottom, for example. As you can see here, now I have these arches going on. And we can also, for example, here set the height size, so we can play around with the height values. This way we can have more variations in our buildings, so you can keep adding overrides to have different layers on your buildings. So we can just plug this in over here and see what it looks. So here's my first look of my buildings. So I have these quite cool buildings made out of my modular pieces. What I also noticed here is that sometimes we can have this gap. So why is this happening? If I would go back to my original OCM information, I can see that there is this line here, but we need to get rid of this line. So I will use here a dissolve flatten edges. So place that node over here, and we just increase this a little bit, and you can see that we got rid of that line over here. So that will fix that issue. Now further from here, if we want to have our building being instanced, we need to use the second output, which is a cloud point. So we will use this cloud point for our instancing. So what I will be doing over here is I'm going to blast away all the modular pieces. So and over here, I'm going to use a blast node. And I want to delete all the slop and the generated slop. And I want to reverse this, so delete non-selected. So this is the unique geometry that is being generated, and I want to keep this. Then I'm going to merge this as well. So merge, and I want to merge this with here the points. So we can see that we now have points, and on these points we want to assign an instance to use in Unreal, for example. Also what we can do here is just make a group here and call this the geometry that is left over, so geo that's left over, just so I can easily afterwards can call this group. Now other interesting information to have here is when I go back up here when I had my basic shapes, in the attribute spreadsheet I have a attribute that's, for example, called building. So if I look for this, we have here building, and sometimes it can say it's an apartment or an office or something else. So we can use this information to then have a variation later on. So what I want to do is I want to have a promotion, so attribute promote, and I'm going to promote that from primitive to points, so this building, and I'm going to set this to maximum. And I want to copy this attribute back into my system. So copy attribute, and instead of color, we can fill in our building. So now if I looked into my spreadsheet and under points, I have now called an attribute building. So when we generate this, so now here we have information for office or apartments and so on. So this is just to show you that you can keep this information from the OCM files into our geometry over here. So you can just copy this information. What can also be interesting is that we have the number of buildings. So what you could do is you can go here, create a metadata import, and then we can create an attribute. So attribute create, and I can, for example, name this building ID, and then this can be a point of a float type, and then we're just going to ask the detail value from the node I just added, which is here then the for each begin metadata. And in this node, I want to ask the number of iterations. So iteration, then 0. So I'm gonna go into this node and ask the iteration number, and I'm gonna store this in here. So let's calculate this as well. So now I have here a building ID, which we can use later on, for example, to filter out on the building number. So if I want to have building 5 to have a different look, I can then easily call building 5 and give it a different look. Now for further working with this, I'm actually going to lock the result, because every time I make a change, it wants to recalculate the system. So I'm just going to lock in the result, so we don't have to always recalculate what's going on. So now here I want to use the split node, so we can split our results. And again, I want to use the geometry left. And now I can switch between the points and the geometry, so I can make a difference for our instancing. So in this case, I want to reverse it, because I'm going to first work with the points. So which you can see here. Now from here we can use another split node, and then we can make a difference between which building it is. So what we can fill in here is we can ask the building attribute, so which I just stored here. So we can ask this building value if it's a certain type. So we can say at building, is it equal to, for example, the office? Then I want to see only the office part. So of course we also need to set this to points, and now I have only the office building. So this is then, for example, my office. We can also keep adding information, so I can copy this and I can add, for example, the apartments as well. So apartments. And now I have included the apartments information here as well. So in here it's just showing you that you can use these different informations to have different modular models. Now further on, we want to assign on each point a attribute called instancer. To do this, we're going to use a labs tool called a value remapping or replace. So let's plug this in over here. And by default, it's going to look at the attribute called name. So in our case, the attribute name, and here we have our model stored, the name of our model being used. So corner, a wall, a top wall, a border, and so on. So we can look on these attributes. Now we can add these attributes by adding this plus icon, but also new here is a button for initializing values. And when you click this, it's going to automatically look at all the different values we have. And this is then very useful. So for all these models, I want to create an Unreal instance for then using a instance from Unreal. So in here, only thing I don't need an instance is actually for the slide slope, which is this generated geometry. So I'm going to click on the remove icon over here. And then now I want to change the attribute from this value to another value. What is also important here, before we can do this, we also want to rename it. So we want to rename it to the Unreal instance attribute. And now here I have an Unreal instance. Now let's go to Unreal and grab a reference. So here in Unreal, what we'll be doing to get our reference for our instance, I'm going to go to the model that I want to have and right click and copy a reference over here. So click on this and then going back in Houdini. So in this case, I have a reference for the border and I'm just going to copy paste the reference from Unreal. And now it says static mesh file. If I look to my attributes now, we will now see here the static mesh names, which is then a path to the mesh there. So we will have to do this for each individual model. So we'll go back to Unreal, get the path, paste the path in here. So I'm going to skip this part. So here everything is now set up for an instance. So we all have that ready to go. Now in here I have this split and I have also another variation. So what you could do is just copy this node and we could start linking other models in here depending on what you want. Also here is another example. What I did here is a wrangle, and I said on the first floor I want to have a different corner model, and I changed the name attributes from the normal corner model to a corner bottom model. Also the left is then a left bottom model. So I just changed these names, and now in here I have added a new model slot for the new bottom corners that I have. So once this is set up, we can then merge these together. So this is set up, and then we have still here the geometry that is left over, and we can also merge this further down here. Now most of the time what I will be doing is I want to have two merge nodes, one for instances. So in here these are all instance, and I'll want to have another merge node, and this is for all geometry. So geometry. So it's important to know that you need to keep this separately, and then on the end you're going to merge first the instance and then the geometry. So this is just important to know when you're working with instances. So now I want to test this out. So we're going to select the whole thing over here, and we're going to create a digital asset. So I'm going to type a Shift-C, which will create this sublevel, and right click, create digital asset, and give it the proper name. So now this is being saved. We now have this menu to add further parameters. So what you could expose is, for example, the file that is being used, the OCM file. But in this case, I'm not going to fill in anything. So now let's jump into Unreal and see if this is working. Now here I'm in Unreal, I have the plugin installed, and I can now just drag and drop my file, and after a moment our city is then being calculated. And as you can see here, everything is working as it's supposed to be. So I have all my walls being set up, and I have different kind of buildings. So in here I have these buildings with a different color here, and then I have these green ones. So that's pretty cool to already see working. So also here I can see different variations as well. So that already works nicely. So this was the video for generating buildings from OCM files. So from here you can then keep pushing it further, add more variations, add for example an interesting roof. So we have some template geometry here, but you can adjust this more to a roof shape if you want to, or you can just delete it. So I hope you enjoyed this video, and next video will then be covering some of the road systems, so we can actually have a road. So thank you for watching, see you in the next one.